Okay, so what we're going to talk about today is Dalton's law of partial pressures. And Dalton's law says the total pressure of a mixture of gases equals the sum of the pressures that each would exert if it were present alone. So, and the idea behind this is, let's say we have a box and it has 3 gas particles. I'll draw little bushes to indicate movement. Pressure, as you know, is caused by collisions with the side of the container. So if I have a different gas, which I'll represent as open circles, and I add it to those, this will also have collisions with the side of the wall, and the pressure is based on the collisions of just that gas. So the total pressure is going to be the pressure of closed circle gas plus open circle gas. So it's a pretty simple law, makes a lot of sense. Alright, so here's a Dalton's law problem. We have a gas mixture made from 6 grams of oxygen, 9 grams of methane in a 15-liter flask at 0 degrees C. Okay, and we want to know what is the total pressure of the vessel. Okay, so we can take a look at this and say, alright, so if we have 6 grams of oxygen, we can figure out how many moles that is, and we can figure out how many moles of methane we have. And once we have that, we can use PIVNERT to find the total pressure, right? Because we have volume, we have temperature, we have moles. Okay, so let's figure out how many moles we have. If I have 6.00 grams of oxygen and 32.0 grams of oxygen is 1 mole of oxygen, this is going to give me 0.1875 moles of oxygen. And as I always say, take sig figs pretty far out, right? Because we're going to round at the very end. If I have 9.00 grams of methane, what I know is 1 mole of methane is 16.05 grams. And this is going to give me 0.5607 moles of methane. So if I add these together, moles plus moles, I get a total of 0.7482 moles total. So now I can solve for pressure. Pressure is PV equals nRT. P is going to be nRT over V, and that's going to be total moles is 0.7482 moles times my R, which is 0.08206, times my T, 0C, so that's 273 K. Now these are liters, atmospheres, joules, mole, times 273, and I'm going to put that over my volume, which is given to me as 15.0 liter. And if I punch that, I'm going to get 0.7482 times 0.08206, which is my R, times 273 equals divide by 15 liters, and I get 1.1. Now I want to look at the sig figs here. I've got 3, 3, 3, so I want 1.12 atm total pressure. But it also asks me what is the partial pressure of each. And that's pretty easy to find because I want to know what percentage of this comes from each substance. So I know what the total moles is, so I can just divide each moles by 0.7482 total, right? And if I do that for oxygen, I get 0.251. So if I multiply 1.12 atm times 0.251 for oxygen, I get, let me see, 0.281 atm. And if I want to know the pressure that comes from the methane, either I can multiply the percent times the total pressure, or I can just subtract, right? Because the total pressure has to add up to 1.12, so 1.12 minus 0.281 is going to give me 0.839 ATM from methane. This is from oxygen. Okay. Okay, the study of effects of certain gases on plant growth requires a synthetic atmosphere composed of 1.5 moles of carbon dioxide, 18 mole% of oxygen, 80.5 mole% of argon. Calculate the partial pressure of oxygen in the mixture if the total pressure of the atmosphere is to be 745 torr. Okay, so it looks like all of these, like 80.5 plus 18 plus 1.5, they add up to 100, right? So I'm just going to take the percent. So partial pressure of oxygen is going to be the total pressure, which is 745 torr. And I'm going to multiply that times, let me see, oxygen is 18%, so 0.18. And when I do that, I get 134.1 torr of oxygen. So, looks like 2 sig figs. So I'm going to call it 130 torr. Okay. B, if the atmosphere is to be held in a 121 liter space at 295, how many moles of oxygen are needed? Okay, so all I'm going to do is take I have my torrs that come from oxygen, and I'm going to convert this to ATM by dividing by 760 torr. And when I do that, I get, let me see, whoops, where's my pen? 0.1764 ATM. Okay, so now I'm solving for moles. So I have PV equals nRT. So N equals PV over RT. My pressure is 0.1764. My volume is given to me here, 121 liters. I'm going to put that over R, which is 0.08206. This is ATM, this is liters. Liters, atmospheres over moles K. I'm at 295 K, so K is 295 K. K's will cancel, liters atmosphere will cancel, I'll be left with the units of moles. And if I plug and chug, I will get 0.164 times 121 equals, divide by parentheses, 0.082, 0.08206 times, that should be 295. 295, close my parentheses, and I get 0.881 moles. And it looks like I've got enough information to give me just 2 sig figs. So it's 0.88 moles of oxygen. Okay.